Hydrated crystals. Many ionic compounds have a fixed quantity of water molecules bound within their structure. So the way we show that is here's copper sulfate, and it has 5 water molecules bound within it. So we have this little asterisk here. So the mole ratio of water to the dry crystal will be 5:1. Okay, so let me just erase that so you can see it. 5 water molecules, 1 compound, ratio is 5:1 in this hydrated crystal. And hydrated, of course, means something to do with water. Crystals that do not contain waters of hydration are called anhydrous crystals. The anhydrous form of a salt will look very different from the hydrate. As seen on the previous slide, the hydrate of copper 2-sulfate is a bright blue color. When all of the waters of hydration are evaporated away, the color is white. Anhydrous crystals will absorb water from the air around them and return to a hydrate. Anhydrous crystals can be used as drying agents, also called desiccants. Below is a list of some uses of desiccants. Keeps food crisp, prevent the growth of mold, protect products from rusting or obtaining water damage during shipping, maintain low moisture levels in pharmaceuticals, to protect livestock from harmful levels of moisture, as an indicator of moisture level, as a means of air conditioning, as a method to remove water from solvents. Some examples of desiccants are calcium sulfate, calcium chloride, cobalt 2 chloride, silica gel, activated charcoal, and sodium benzophenone. In the lab, you can actually find the formula of a hydrate by heating the crystal to remove the water. Then, find the mole ratio between the dry crystal and the water just as you would when finding an empirical formula. Same process. So here's our mystery. We have copper sulfate, and we know it's hydrated, we just don't know how much. So it heats up. We get a certain amount of grams of copper sulfate, which we're going to turn into a molar number, and we'll do the same thing with the water. So we need some very precise measuring here. And then we find the mole ratio, just like we did for the empirical formulas. So we're using the empirical formula process again, and we're going to do it another way, a little more shorthand. So we heated a hydrate of magnesium sulfate, and we found that after we did the heating, that it was 51.3% water by mass. What's the formula of the hydrate? First, find the percent of the crystal that's left over and the water expressed in grams. So if there was 51.3% water, that means we have 48.7% magnesium sulfate. We turn that into a gram mass. We assume a 100-gram sample. We get 48.7 grams magnesium sulfate, 51.3 grams of water. Convert to moles. So magnesium sulfate, you can add up the atomic weights of magnesium, sulfur, and 4 oxygens. Make sure you count all 4. And you'll come up with 120 grams per mole. So that we do the division here. We have this many moles of magnesium sulfate. Water, again, to get this here, the molar mass, we have oxygen, which is 16. We have 2 hydrogens. So you get 18 grams per mole. See, I'm making you do this one. I did the simple one. You divide through, you get 2.85 moles of water. Do you know what the next step is? Kind of work it on your own before we go to the next slide, please. We now find the mole ratio of the water to the dry crystal. Who had fewer moles? Well, that would be the magnesium sulfate right here. So we're going to divide both numbers by 0.405, and we get magnesium sulfate as 1. Divide the same number by itself, you get 1. Water, we get 7. So our formula will be magnesium sulfate asterisk 7 water molecules, just like that.